Many people assume that machines are objective, but are they really? Our next speaker is not so sure. Zoe Stanley-Lockman is an Associate Fellow at the European Union Institute for Security Studies based in Singapore. Zoe's work focuses on issues related to artificial intelligence, autonomous systems, and other innovations. And today she's here to ask and hopefully to answer one very important question that's lingering in the back of many of our minds at the moment. Is it possible to build machines that are free from human biases? Well, let's find out. Please join me in welcoming to the auditorium, Zoe.
Hi, I'm Zoe Stanley-Lockman. I'm a former Associate Fellow from the European Union Institute for Security Studies, the EUISS, where I looked mostly at the impact of intelligent enterprise and other burgeoning technologies on their impact on security and defense. And today I'll be talking about a subject that is more relevant to the civilian and commercial sphere, one that I think is really going to touch on all of us, and that is algorithmic bias, or also machine bias. And over the next 30 minutes or so, we're going to be talking about how human prejudice has been imported into intelligent enterprise, and looking a little bit more closely at some of the examples, and then later on, what can actually be done to make sure that in a world where we're focusing more and more on artificial intelligence and on machine learning, that we can ensure that the systems will be as objective as possible and not just exacerbate the bias that we have as humans today. So one of the most prominent cases, which I thought would be a good place to start, was the findings from a ProPublica study from a couple of years ago, where they looked at a county jail in Florida in the United States and found out that they were using machine learning to create a risk assessment of criminals, trying to determine who would be the most likely re-offenders. So who would be the ones to have a subsequent offense. And ProPublica actually revealed that over the 10 or so years that the system was being used, there were more and more Black people who were found to be at higher risk levels, even though they were not the ones who necessarily re-offended. So it became a bit of a scandal, rightfully so. And here we have two examples of individuals who you can kind of see the white criminals were the ones who had lower risk assessments, but actually ended up being re-offenders. And the Black people is just because the data that was being used suggested and implied that Black people would be re-offenders, even though that's not the case. So although this has been a big scandal, not as much has been done about this, and it's one of many, many ways in which we see different bias that humans have and that have been incorporated into data sets upon which machine learning is trained and then uses, can actually exacerbate the problems that we have today. A somewhat famous example from a couple of years ago was Tate Wheats, which was a Microsoft account of a she-bot who was on Twitter, and she said that she was learning from all of the humans who would be interacting with her, and within one day was forced to be shut down because she started saying incredibly flagrant things, very sexist, talking about how horrible feminism was, as well as being basically a robot Nazi. It was very scandalous, and it became a huge PR bluster. And we're going to see how public relations becomes a bigger theme over the course of the presentation. So here, I've also included a pretty important phrase in the world of AI and intelligent enterprise, which is, if you put a flaming garbage pile in, then you'll get a flaming garbage pile out. So it, again, refers to the data upon which these kinds of systems depend. If you have bad data, if you have trolls and people who have their own opinions that are being expressed on Twitter to play with the robots and the different algorithms, if that's what's going in, then that's exactly what's going to come out. A machine and an algorithm can be no better than the humans that have created it. Or hopefully we'll be able to prove that wrong. So those are two of the kinds of main examples of prejudice and of bias, which has been imported into artificial intelligence. Now I'm going to go through, based on some information from Google, about 3 different kinds of bias that we see, and then we'll be able to place different kinds of examples into these categories. So the first is interaction bias, whereby users inject bias into the algorithms through their own interactions with them. So here in this example, users were asked to draw a shoe. And so many people drew different kinds of shoes, but only very few people drew high heels. So the algorithm wasn't able to identify high heels as shoes. So you can kind of guess, maybe if you have fewer people who are thinking about high heels, if you have, for example, fewer women in the room, then it means that the system isn't going to be able to pick up on this diversity of opinion and the diversity of kinds of objects that we would find. The second kind of bias is a latent bias. And here we have an interesting example of taking data over the course of history. So here, this example is regarding physicists, looking at all of the physicists throughout the ages, but the system might not be able to identify a female physicist, because if you're looking historically, then obviously the data set is going to be very skewed towards males. So because a lot of the data that we're using is dependent on long historical trajectories, it means that it's often going to be skewed toward more privileged individuals, and oftentimes it's going to be white men. So what does that mean, not only for women, but what does that mean for other minorities? What does that mean in terms of lack of diversity and discrimination? So we've talked a little bit about the 2 main forms of prejudice being racism and sexism, but there are various other kinds of issues, also with sexual orientation, income level, religion, country of origin, sometimes also biology can come into play. So the more you're basing your information on, again, like the flaming garbage pile, then the more that you're going to have a bias towards something that doesn't exactly reflect the current moment in which we're living. Another problem, which I'd like to get into with latent bias, in addition to historical information, is that some of the largest sources for the data sets that are training machines are from Wikipedia. And Wikipedia does not necessarily have a very diverse source of users that are actually putting in the information. Only about 10%, a little bit less, identify as female, or at least that was the case back in 2011. Hopefully today, a little bit more diverse, and that the same goes for different socioeconomic and racial demographics as well. Another big source, and this is an especially important one for identifying bias, has been the quote-unquote treasure trove of emails from Enron, which you might remember from the massive scandal. But if you're looking at Enron, again, that's only one particular company. You're looking at emails between a select group of executives. So even though it's a system, or excuse me, a data set that's been used repeatedly to train different machines, it is a problem because you're only kind of dipping into the same pool over and over again. The third kind of bias that I'd like to talk about is selection bias. And this is data that's used to train an algorithm, but it overrepresents one population. So that means that it's ignoring others, or only operating better, not operating as well, rather, for specific groups. We'll see on one of the future slides a pretty famous example of this that we will be getting into. One of the key terms that comes up over and over again when we're looking at bias is word embeddings. So these are kinds of the associations that are made, and if humans make them, then it follows that oftentimes the machines will make them. So here we have an example of the difference between men and women. And sometimes you need these embeddings to, for example, if you have queen and king, if you're using a machine to analyze something that's related to history, there's obviously a difference between a queen and a king. Obviously a queen being associated with a female, king associated with a male. The same could be said for sister, brother, daughter, son. Some of these terms which can be considered a little bit more neutral, a little bit more objective. But the problem is that when machines have been trained to look for these kinds of words, they've come up with other examples. So here in the main image, you can see leader versus assistant, boss versus employee. Another famous one that comes up over and over again would be doctor and nurse, or pilot and flight attendant. So, you know, it on the surface seems like it's a problem. And if you go even deeper, it becomes an even bigger problem, because these are the kinds of machines that are making important decisions about who is qualified for jobs, who's qualified for housing loans or reinsurance, and many kinds of things upon which our daily lives depend. So if these are the kinds of associations that are being made on the surface, then you're creating an implicit order of people that have implications for very, very broad items in their daily life. So here we're going to return to that third category of bias, which I had mentioned, and talk a little bit about the willingness versus the ability to kind of correct human bias. So a couple of years ago, 3 years ago, there was an issue that Google had all of these quote unquote neutral categories to categorize people's photos. So you can see on the bottom left that the categories were skyscrapers and cars, airplanes, trying to identify what the objects and the subjects in the photos were. The problem was that it found Black people to be gorillas. Obviously, as soon as this was pointed out, Google apologized and took instant steps to correct this. Did not at all mean to imply anything about Black people. But the problem, which is actually just revealed in the past 2 weeks, is that instead of being able to fix this problem, they actually just removed gorilla from the vocabulary. So if any of you go to Google Photos right now, you'll see that if you type in gorilla, you're not going to get anything. If you write elephant, you'll get an elephant. If you write giraffe, you'll get a giraffe. But if you write anything to do with monkeys, they've actually just erased it. So it kind of goes to show in a very recent way that it was a quick fix. Google had a big public relations, a big PR blunder because of its algorithms implying that Black people were gorillas, which is obviously not the case. But instead of actually fixing it, they just kind of put a Band-Aid over it. So it kind of goes to show that sometimes it's not just a willingness, but it's also a question of ability. Is it possible to remove bias? And oftentimes, some of the biases are even subconscious. They can be implicit. We won't even notice them at first. So how can you even know if a data set has an implicit bias in it? Another associated question is, how do you use science, or how can you kind of have a very strong methodology to approaching the issue of mitigating unintentional bias in artificial intelligence, when a lot of these biases don't really have scientific categorizations underlying them? Sometimes it's just personal, sometimes it doesn't show as well in a group. So kind of using science to approach an unscientific subject can be a very large problem. So hopefully we'll find that you can have the ability to correct bias. That said, is very much about willingness as well. So now I have a couple of slides with a few fewer pictures, because I'm hoping that the text on them will really shine more itself, because I want to go through that next topic of willingness and say, okay, well, now that you've been enlightened to the issue, or maybe it sparked your interest, what can you do to actually be willing to correct some of these issues and make sure that if we're relying more on machines, that they're not as bad or even worse than we are when it comes to discrimination. So related to the question of willingness is responsibility. And the first question is, what can governments do? So there are 3 different categories of items, and I'm not saying that one is better than the other. That's obviously going to depend as well on which country you're talking about, what form of government. But if we look at regulation, legislation, and investigation, there are definitely powers that governments can use to make sure that we have fairness and lack of discrimination at least being attempted while we're supporting more change and more propensity towards intelligent enterprise. So in the realm of regulation, one of the things that we could do is to have more recent data sets. So if we think back to the physicist example, one of the problems is that if you need large enough data sets to be able to train the algorithms, it means you have to go really far back in time. One of the issues is that the current data sets, which of course exist, are often protected. So sometimes it has to do with intellectual property rights. More often than not, it's non-disclosure agreements. Again, that's why the Enron emails were so important, because even if that information would have been confidential previously, it was forced to become public. So is there a way that governments can improve access, at least to train algorithms to information without disrespecting non-disclosure agreements? This would be, it can be a somewhat controversial issue, but it's one that should at least be discussed. Another one would be to incentivize companies and different programmers to evaluate their own software and to try to establish their own best practices, because sometimes there are problems with independent testing. How can you have independent testing when you don't even have access to the information if you haven't signed that NDA? Again, it's a big question. So the government could actually help incentivize, financially or otherwise, ways to kind of supplant the testing mechanisms which currently can't be done. In the realm of legislation, there is a very strong legal question, which is how can we treat people differently? So right now in copyright law and in fair use laws, everybody has to be treated the same. Of course, this is a key tenet of any liberal democracy. This is a key human right, is to treat people equally, probably the top of the list. But what does that mean actually in more of a technical sense? Is it possible that different countries would be able to legalize, specifically for the purpose of AI, ways to approach different demographics differently and to quote unquote treat them equally, which would paradoxically make it more possible to have them be more equal in the end? And then the third category of what governments can do, and again, it goes back to willingness and responsibility. This is the one I find the most interesting, is to create an independent investigatory governmental body. So this was a proposal from Ben Schneiderman from the United States, who looked at the US National Transportation Safety Board and said, okay, we have this independent body that's meant not for regulation. That's a very key point. It's not for regulation, but it's for investigation. So to make sure that transportation stays safe, is there something that we can do to make algorithms safe and to make software safe and to try to include ethics and as well as machine bias in that category? Something that hadn't been proposed by Ben Schneiderman, but I think would also be very interesting, is to see if an international version of that would be possible. You could imagine, for example, the European Union, you could imagine the United Nations, or one of the more technically oriented international organizations work on this as well. So this next slide is on the same theme, but now instead of looking at governments, we're looking at businesses. So we looked earlier at the example of the gorillas from Google and that massive PR blunder that they had. But now we see that, well, they kind of found a quick fix to it, but they haven't really found a way to truly correct it. So the first thing is to kind of have that willingness to treat machine bias as more than a PR concern. Again, we're expecting massive impacts on our society. And if we're just looking at it from a public relations point of view, it means that we're not taking seriously enough the gravity of the situation at hand. So one of the ways to do that would be to commit to greater workplace diversity to mitigate interaction bias. If you remember, interaction bias was the example with the shoes being drawn and recognizing high heels as not as shoes. So the more people you have in the room who come from different backgrounds and who have different opinions and perspectives to share, the more likely you are to have more of a comprehensive approach. So what can be done? Businesses can focus more on making sure that those people get in the room in the first place. Another thing to do could be to consider vetting procedures for programmers and to look at the implications of bias and make sure that they take it very seriously. On a related note, a lot of programmers who are learning how to do this in university right now have ethics courses, and they have those requirements that they have to fulfill to graduate, not only in the United States, but in a lot of other countries as well. But the problem is that it's kind of a box to check. So there needs to be something done so that people understand what the impact is of their work on society more broadly. I think more of a hands-on approach to ethics requirements, not only with universities, but also with businesses or even in partnership with businesses, would be a really great way to do that. Something else that could be done is when you're funding, if you're an investor or if you work in an R&D branch in a company, to attach fairness requirements and make sure that you're looking into that, because the sooner you invest in it from the outset, the sooner that these issues are going to be looked at and explored more fully at the end of the kind of life cycle. Then something else, and then this one I actually was surprised to pick up on more from DARPA, which is the Defense Advanced Research Projects Agency, which is part of the Department of Defense in the United States. And I recently listened to an interview with an anthropologist who works full-time at DARPA. And if you talk, if you're familiar at all with DARPA, you know that they almost exclusively hire people from natural sciences. These are people who are looking into drones that can disappear into thin air because they're made of biodegradable materials. These are people who created the internet, who invented GPS and microwaves, really groundbreaking technologies. But to hear that they have an anthropologist on board means that they're considering the implication and the relationship between social responsibility and technology itself. I think if they're doing it, more people can as well. So in addition to making sure that you have those strong ethics requirements, think that partnering with more social scientists who understand the society that is going to be implicated would give companies a great sense of social responsibility. A lot of this is already being done. I mean, it's not the most original idea, especially after some of these PR blunders. Microsoft and Google, et cetera, have had very, very strong initiatives and programs in place working with universities on some of these issues. So right now, while it's also a question of awareness, it's also kind of seeing a couple of years from now how much further we get. The third category of responsibility is looking at programmers. And here I wanted to kind of look more at an individual level, because sometimes it's not just what businesses can do, and also recognizing the differences between large companies as opposed to small and medium-sized enterprises, but also just looking more on an individual level. So I think a really key point in this regard is that oftentimes people will look at a low margin of error and assume that that's a good thing. In many cases it is, but it doesn't necessarily mean that you have eradicated any bias. If you have a low margin of error, you still can have an implicit bias in there. So I think not assuming that one leads to the other is really important. There are two different ways that data can be de-biased. One is additive, and the other, well, the first one is removing bad information. So you kind of are taking something away. It's very hard to do because, again, oftentimes the bias is implicit. Sometimes it's not recognizable. So sometimes it can be more of a game of playing whack-a-mole than anything else. The other would be adding an extra layer of judgment. More complicated also because that extra layer of judgment might interact with how you're treating different demographics differently. But in any case, I think individual programmers and small and medium-sized enterprises will have to kind of make the decision and try to see which approach they want to take to debiasing data. And then I had also mentioned just a minute ago that there are many initiatives that are being led by large companies like the Googles and Microsofts of the world. Now we're seeing more and more that are coming out of MIT, other laboratories, and also civil society organizations. So here I've listed a couple of them. I'm hoping that it'll pique people's interest so that they'll go to their websites and look at the really great work that they're doing. So here I've just given 5 examples, and I'd really be thrilled to give more information about them if I can on a more individual level. And then the last thing that I think programmers and, again, smaller companies or those thinking more on an individual basis can do is to try to write programs that are identifying the bias. Again, it's not always possible, but already we're talking about how machine learning in certain cases is more advanced than the humans themselves. If we can get to a point where that is also true of identifying bias, then I think that's probably the most optimistic that we can get. That's where we're going to hopefully have intelligent enterprise being able to transcend our transgressions as humans. So again, there are some existing tests that look at word embedding, and it would be great if there are kinds of biases that would be identified, and also tests that could be used and applied to different programs to make sure that people are being as objective as possible. So earlier we gave the adage, flaming garbage pile in, flaming garbage pile out. But now I'm hoping that if we focus on awareness, on the responsibility that we all share, then we can kind of get rid of that garbage pile and we can lead to a brighter future. Thank you.
That was Zoe Stanley-Lockman, Associate Fellow at the European Union Institute for Security Studies. Don't forget you can join us in the networking rooms now for a live discussion. It's your chance to ask our speakers questions without the added pressure of standing up in a room full of people. You can also have your say by joining in our live polls today, which you can access from the menu bar at the top of your screen. Please take a few minutes to tell us what you think about artificial intelligence and the future of intelligent enterprise. We'd really appreciate your input. We'll see you back here at 12:40 p.m. Eastern Standard Time. That's 9:40 a.m. Pacific Time for our next stream of sessions, which will focus on big data and even bigger ideas. We'll see you soon.